All right, today we're going to dive into a really fascinating field report from Nominex research. It's one of those stories that starts with a simple, everyday problem, but ends up challenging a huge assumption about how we're supposed to be building AI memory. And it all kicks off with this incredible line from their paper. I mean, just think about that for a second. It sets up this central mystery that really gets to the heart of AI agents. How on earth could giving an AI more information actually make it perform worse? Well, stick around, because the answer reveals this massive blind spot in the industry. So look, this wasn't some abstract theoretical project. Nominex actually built a team of 8 specialized AI agents to help run their company. They had an agent for infrastructure, one for marketing, a coordinator, the whole crew. The only problem? They were individually brilliant, but as a group, they were a team of amnesiacs. Can you just imagine the chaos? Every single time they started a new task, it was from absolute scratch. The marketing agent had no idea what the infrastructure agent decided an hour ago. They couldn't build on past successes or learn from their mistakes. There was zero institutional knowledge, which, makes real teamwork pretty much impossible. This was a real-world operational nightmare. Now, you'd think the solution here would be some incredibly complex, state-of-the-art tech, right? But Nominex went in the complete opposite direction. They built a solution they cheekily called poor man's memory, and it was so straightforward that it almost felt, wrong. And this is absolutely the key. They intentionally dodged all the complex stuff the AI industry is obsessed with right now. No vector databases, no complicated RAG pipelines, none of it. They just used simple, organized text files and tracked the changes using Git. Honestly, this simplicity is probably why nobody else ever tried it. In a world chasing complexity, it just didn't look like a serious solution.
The way it works is just brilliantly simple. Okay, step 1. Memory is organized into clearly named files. An agent knows that to find old decisions, it just has to look in decisions.md. Easy. Step 2. To save on processing, the agent only gets a little peek, just the last few entries from each file, at the start. But, and this is the most important part, the agent knows the full files are there, and it can decide for itself to go and read the whole thing whenever it feels like it needs more context.
So the fix was working for them. But to really understand how well it was working, they needed to measure its performance. And that's when they slammed right into the industry's big collective blind spot. I mean, this is the obvious question, isn't it? There are tons of tools out there for testing AI memory. So why would they go to the trouble of building their own from scratch? Well, the answer really gets to the core of the whole problem. Okay, just look at this table. It shows the gap so clearly. Every major benchmark out there was built to answer one question. Can a single agent remember our previous conversation? But that wasn't Nominex's problem. They needed to answer a totally different question. Can a team of agents learn from a shared history to make better decisions together? Nobody was even measuring that. And this slide just lays out the 2 competing philosophies perfectly. The common approach, RAG, basically treats the agent like a passive consumer. An algorithm decides what's relevant and just spoon-feeds it to the model. Poor man's memory does the complete opposite. It treats the agent as an active, intelligent participant. It just gives the agent a well-organized library and trusts it to find what it needs. So Nominex built their own tests for their own system. And the things they found were, they were genuinely shocking, and they turn a lot of the common wisdom completely on its head. So let's start with a bit of a riddle. What could possibly be worse for an AI agent than having complete amnesia? Just no access to any past information whatsoever. Having partial memory. And this brings us right back to that wild quote from the beginning. It turns out that giving an agent an incomplete picture is way, way more dangerous than giving it no picture at all. So in their tests, whenever an agent was given just half of a 2-part answer, it didn't hesitate. It didn't say, I think I'm missing something here. Nope. It just responded with absolute confidence, generating a beautiful, well-written answer that was completely and utterly wrong. They call this the partial context trap, and it's so dangerous because partial information tricks the agent into losing its own sense of uncertainty. Okay, the second big discovery was just as mind-blowing. They calculated that a whopping 83% of the total benefit of having memory came from the moments when the agent autonomously decided to go and search for information itself. The stuff they preloaded into its short-term memory, it barely made a difference. And this chart just hammers the point home. Look at that. The tiny little bar on the left, that's the performance boost from preloading context. The massive bar on the right, that's the boost from letting the agent go find the information itself. The difference is just staggering. It really makes you wonder if the whole industry's obsession with bigger and bigger context windows is missing the point. So what does all this add up to? Well, Nominex argues it points to a totally different way of thinking about AI memory. The goal should be to build a well-organized archive that an agent can explore, not just a temporary cache that we stuff facts into. The first big principle is that good structure basically replaces the need for fancy search. You don't need a complex algorithm to find a past decision if the agent already knows that all decisions live in a file called decisions.md. The organization itself becomes the search engine. And the second principle is all about a shift in trust. Instead of relying on some black box algorithm to decide what's relevant, this approach relies on the agent's own intelligence. It lets the agent navigate the information, weigh conflicting sources, and decide for itself what's important. It's about putting the reasoning back into the hands of the reasoner. And this quote from the paper just sums up the whole philosophy perfectly. The job of a memory system isn't to guess what an agent needs and shove it in its face. The job is to make knowledge so well organized and so accessible that the agent can reliably find whatever it needs exactly when it needs it. And all this leaves us with a really critical question for anyone building with AI. Are we actually creating well-organized libraries that empower agents to think for themselves? Or are we just building bigger and bigger closets, stuffing them with random facts, and just hoping the right answer somehow falls out?